have to understand exponents. You have to remember all your rules because they are exponents, so they follow the rules of exponents. If you have like bases right here, so you're multiplying, got it right. What do you do with exponents? Add. Right? Okay, what do you do when you have a power to a power? You multiply. What do you do when you're dividing? Subtraction. So this means right here, when I'm multiplying, I'm actually adding the exponents, right? So I'd be adding logs. Here, I would be a power to a power. I would be multiplying logs. Here, I would be subtracting logs. That's your rules of logs. They follow the rules of exponents because they are exponents. All right, first one is just giving itself a name. We've used this a bunch. It's called the change of base formula, right? And we've used it only with base 10. It actually works with every base, but base 10 is the one that is what we use, because why would I use a base 10?
Because that's an original.
What's on your calculator?
Base
10. All right, so when you do this, if I give you something weird, like 81 and 27, can you do that one in your head?
Can't say I can.
No, it's too hard, right? But your calculator will do it for you. What do you always divide by? The log of the base. So you take the log of 27 on your calculator, divided by the log of 81 on your calculator. This base is always the division. Okay? And it will give you the answer. And it will tell you without any work. You don't have to do any of the exponents or the set equals to x. It will tell you. All right? That's called a change of base formula. It works with any base. I use base 10 because that's what's on your calculator. Could I use base 5 if I felt like it? Mm-hmm. You could. Why would you? I can't figure out one reason why you would do that. But it would work. Everybody understand? All right. Now, do yours. Type it in your calculator. Tell me what your answers are to make sure you're doing this right.
Shoot.
Which is 1.6.
Did everybody get 1.6?
Would be 1.7 actually. 5.66.
Everyone knows how to do it on your calculator? Can you do it?
Hold it. Let me get mine.
Okay, voices are off. The reason you have to know this is you see these lovely calculators? And even the one Tyler has, a lot of the colleges are going to where calculators are not allowed to use them anymore. The only thing they can use
That's why they don't take
is
calculus.
this.
That's why they don't take it. They use it upside down.
So I'm just warning you, the colleges are going away from, it was a huge push like 5 years ago that this was in every classroom. They've gone away from them now. So you have to know how to do it.
Yeah, but the thing is, I don't understand. We have this stuff to use it. Why don't we?
Because they want you to use your brain. I know it's a hard stretch. But
You challenge yourself. There's no reason to.
I know. Okay, here we go. Now, these are your rules. Voices are off. Now, these are the product rules, the quotient rule, and your power rule. It's what we just talked about. Okay, when I'm multiplying, what am I really doing with the exponent? Adding. So multiplication means addition of logs. So what would division mean? Subtraction. I'm truly subtracting the logs. A power to a power, what are we doing? You're multiplying. Power to a power, you're multiplying. That means whatever the exponent is belongs in the front. You are multiplying. Good? It follows the same rule as exponents. Nothing changes. Are you going to remember them? A little iffy. Okay, these two identities that you've learned, you have to remember. We will use those constantly when we're reducing. You need to be able to recognize them. They've got to be in your brain by now. So when you have the two bases, remember they cancel, giving you the x. The same thing here. Base and base are the same, cancel, giving you the exponent. All right? You've got to remember those. We will use that to reduce this all the way through. Good? You awake that? Here we go. We're going to do it first with numbers. So it's really simple. Then we're going to make it a little harder. So now I've got log base 2 of 5 times 6. What does multiplication mean? Adding. So I'm adding these two together. That means log base 2 of 5 plus log base 2 of 6. Okay, do we know that one automatically? No. So you'd have to use your calculator to find it, or we leave it. Now, this, you know you complain about stuff you never use? This is one of them.
All of them I found out we never use.
No, you will never use it except on the college entrance exams and your calculator.
I don't need one of those.
Because what this is from, this is even before I learned math. They gave you a log chart before you had the calculators that did it for you. So you'd have a log chart, a huge table. And in the table would be what the logs equal. So you go to the table, you would look up log base 4 3, and it would give you that answer. All right? They want you to be able to do logs using the table, basically. But they don't give you the table, they just give you one of them.
Can we just plug it in our calculator?
No, because you're going to have to show them the work.
If I just plug it in my calculator, how many points do I get?
All of them.
I have to write it.
All right, don't care. Okay, here we go. So I have log base 4 of 192. I have to calculate that without a calculator. Now, they give you log base 4 of 3. This is given to you. Good so far. Okay, the two numbers in there are 4 and 3. Agreed? Because I've got the log base 4 of 3. That means I have to change 192 into 4s and 3s. So like before when we factor treed, we always went to prime numbers, right? We would have started with the 2 and went on. Am I going to do that here? No. What number are you going to start with? What's the bigger of the 4 and the 3? 4. You usually take out the larger ones first to make your life easier. So we're going to start with 4. How many times does 4 go into 192? 48. Good. Can I put 4 into that again?
Yep.
4 and 12. 4 and 3. So 192 is 4 cubed times 3. Good so far. All right. So I'm going to replace 192 with 4 cubed times 3. What does multiplication mean?
Addition.
Addition. So now I have to change this multiplication into addition. So it's log base 4 of 4 cubed plus log base 4 of 3. Good so far. Do you recognize your identity? Yes. The bases are the same. This is your identity, so it cancels, and my answer is 3. So this is 3. Yes, Logan.
Not do the, you know how you want 4 times 48? Do you not do the 4?
No, because you want it in 4s and 3s, so you'd leave it.
I didn't understand what he asked me. All right. So now I have log base 4 of 3. Do I know what that equals? Yeah, because that was what was given. That's off your table. So log base 4 of 3 is 0.7925. Add them together, and I got 3.7925, and I'm done. That's how you evaluate logs without a calculator.
That's crazy.
It is crazy. Your turn. Do you want me to leave this up?
Yeah, leave that up there because I'm
Leave that up. Don't move it.
preferring.
Okay, go. What number are you going to plug in first? 4. Because 4 is the larger. Could you do it with all 2s?
If you wanted to,
You can. It's going to be a little bit harder, but we can do it.
I got the answer. I got the answer.
Who's that? Should get 2.5. How are we doing?
Not good.
I heard there's an earthquake.
Actually, I understand. It's weird. I understand it. He's like, I understand it, but he gave the wrong answer.
And it's actually the concept.
Really, I just only like half a day. So this is like recent. Yeah. Yeah. Yeah, I can probably explain to you because I didn't
I saw something last night or what's it or stuff.
Rondo. What plants crave.
You gave up on life, didn't you?
Boys, stop. Everybody good? Okay, let me show you some different ways to do this. A lot of you, most of you do 4 squared and 2, right?
Yeah.
All right. Now, another way to do that, because some of you didn't see the stop. If you went 4 and then you did this. All right. That's a lot of 2s. How many 2s is that? 2 to the 5th. You can do that. I can say that's log base 4 of 2 to the 5th. Okay, if I'm doing that, what rule do I have to use? What's a power to a power? Multiplication. So where does that 5 belong? Out front. So if you did this, and you put him out front, now you have 5 times log base 4 of 2. Well, what's log base 4 of 2?
0.5.
So what is 5 times 0.5?
2.5.
2.5. Did you get the same answer?
Yes.
Yes. Is the other way easier?
Yes.
Yes. Understood?
Understood.
Yes.
Great.
That way, then what happens to the 4?
Once you break down the 4, you can't use him. Okay? So if you did break down the 4s and you had the 4 squared times 2, you're using the identities, right? Please come here, me. Oh well. There we go. All right, next one, quotient properties. So we go through these properties one at a time, then we're gonna put them all together. Now, when you are dividing, what are we really doing? Subtracting exponents. So if I have 5 divided by 6, I'm really taking the log base 2 of 5 minus the log base 2 of 6. The division means subtraction. Good? Now, down here, I want to simplify the logs, so I want to go backwards. So they tell you to evaluate, you're going one direction. They tell you to simplify, you're going the other direction. Okay, so I have subtraction. What does that mean? Really, I would have never guessed.
Like the short 2 seconds you finally look at me.
Did you know that?
I'm not paying attention.
Wow.
The 2 seconds I'm actually not.
I'll make fun of
Yeah, right back, we're going there. Go. It means divide. Thank you. So that means 32 divided, this changes to division, by 2. What's 32 divided by 2? 16. Now, what base do I want 16 to be?
4.
4. Why, Logan?
4 times 4 is 16.
I know that, but why do I want it base 4?
So it's
I was thinking.
Yes. This is a base 4, so I need to change the 16 to 4. If it was a base 2, I would have changed the 16 to 2. Good? Okay, 4 squared, where does the 2 belong? In the front, because that means multiplication. Or you can recognize this. What is this?
That's
Same base identity. Cancels answers
Slash amount.
2. Are we there? Go.
Go now.
You should be about done.
Oh,
That's the next one.
All right, since Aaron told you.
Cam Newton died.
So the 2 really belongs here.
So
36.
when you put it over.
So this is log base 4.
36 over 9.
Okay, yeah, I'm going to do it with 2 steps. 36 minus log base 4 of 9. Now go. Okay, Zach, good evening stuff. What did you do next? And? To pause this again? Oh, goodness. So we get log base 4 of 36 divided by 9, which is what? Zach, tell me. Okay? Which is what?
cancels.
Oh, that's
So
too
what you
bad.
did just.
No. All right, here, we're helping Zach out. Zach, listen. Log base 4 of 4. Yesterday in your homework, you had to solve these. What was your first step?
He took
You did not.
he didn't do it.
You set it equal to,
I want to equal.
okay, write it out of the log now.
Needed a.
Zach, write it out of the log. Get rid of the log. How do you do it? What's the base? What's the exponent? What's Nope, I like it. Come on.
E.
Do not talk, Logan.
Moving forward to the x equals 4.
Good job. Base, exponent, answer. So 4 to the x equals 4. What is this really to the power of? 1. So what does x equal? 1. So what's the log base 4 of 4 equal? 1.
Did you just know that they canceled?
Yes, you're supposed to know that they cancel it equal 1.
We don't
Not
have-
once did you say that.
Yes, I did.
I'm pretty sure you did that.
We all heard it.
All right, here we go.
Don,
You never listen. Okay, we have a story problem. pHs. Now, we have the concentration of hydrogen, okay, it's given by pH equals log base 10 of 1 over hydrogen. Now, does the base truly matter in here? No. It is base 10 because that's what it truly is, but it could be any base when you're working a problem, so don't let that throw you. So now we have to rewrite that. So I tell you that after the pH level is 4.2. So you're replacing the pH in the problem with 4.2. Everybody good? This replaces with that. Yes? Okay, now I need to solve this. What does division mean?
Subtraction.
Subtraction.
Yes.
So we do log base 10 of 1 minus log base 10 of hydrogen.
Which is 4.2.
No, that's what your pH is. I'm trying to find how much hydrogen is in. Now, you have to recognize this next part. This is part of your homework yesterday. Whenever you have a log base of anything, and it has a 1, what does it equal?
0.
Because anything to 0 equals 1, right? You have to know that one. So you need to know that that guy just cancels out. Basically gone. Okay, I'm sorry for hydrogen. Can I have the negative insert?
No.
No, so we divide everybody by negative 1. Are we good so far?
Yes.
Denton, what's the matter? What? Don't know any of what.
I didn't either about
You're talking.
Yeah.
Go. Any of what?
Any of that.
This is just working with logs. You have to know that division is what? Thank you. You have to know division is subtraction. You have to know this from yesterday. 2 days ago. Actually, 3 days ago. When did I teach that? Monday.
Sunday.
No talking. Well, you need to go back and learn your rules then. Okay, so now, how do I, let's pick up Denton. Here we go. Denton, quiet. Log base 10 of hydrogen equals negative 4.2. Nobody talk except Denton. How do you write that out of a log? Change it to an exponential form so I can do it. Come on. What's the base? What's the exponent? Think with Caitlin. And what's the answer? You're killing me, Denton.
I really don't. Are you alright? We need to call
Here.
an ambulance?
Base,
said you were hurt.
exponent, are you listening? Answer. So it goes 10 to the negative 4.2 equals your hydrogen. That's all they did there. So if there's only one log, it's not always going to be that way. If there's only one log, you write it out of log. You write it into exponential form. Yes. You have to use your calculator. So now you do 10 to the negative 4.2 on your calculator. Type that in. My people in my last class were doing it wrong.
Yep, I got the right answer.
What'd you get?
0.00063.096.
Did it actually give you that on your calculator?
You know, anything?
I got like 0.3.
I got 0.00006.
None of them did this. 6.3,
No, we don't.
10 to the negative 5.
We're geniuses.
Okay.
Mess with that.
Remember, some of your calculators are going to give you scientific, and you need to change it back to regular, all right? Okay, go. You have a problem to do. Do you want me to leave this up?
Yes.
Go. Wasn't there 5060? So 0.0000316 something like that. Okay, good. Okay, power properties of logs. So the next one you have to learn. When you take power to a power, what are you doing? Multiplying. So you're multiplying here. This exponent does not belong there. It must be multiplied, so it moves to the front of the log. That's what the power property is. So it moves here. That's how you get 5 times log base 2 of 6. So powers go to the front. So you're up here. I'm going to give you log base 2 of 5 equals 2.3219. I'm asking you to find log base 2 of 25. What do I need to change 25 to? Which base? 5. How do we know it's 5? No, that's not how you know. How do you know I need the base 5? It gives you that. And whatever it gives you here is what you need to change it to here. Good? So since they gave me a 5, I need to be in 5. 5s or 2s? Go ahead.
I was looking at practice.
Oh, just a minute. So 5 squared. So now I got log base. Where does this 2 belong?
In the front.
In the front. Log base 2 of 5 is what? 2.3219. So it's 2 times
That number.
which gives you your answer. All right, you're doing log base 3 of 7. I want you to find log base 3 of 49. You don't get to use the calculator, so put it away. So you change this to log base 3 of 7 squared. Where'd the 2 go?
Front.
To the front. And what's log base 3 of 7? Which is what?
3.542.
2.4. All good? All right, now. I'm dividing, so what am I really doing? Subtracting. So now I have to do the log, and I have to expand. So expand means we're going the right direction. So I have to take log base 9 of x to the 4th. What does this tell me to do? Subtract log base 4, or log base 9 of 81. What's 81? 9 squared. Okay, do I have to do this step right here?
You don't have to.
Why not?
Because
It's just excess.
Yes, because that's an identity. I can skip this if I recognize that. Correct? Okay, so now I have 4 log base 9 of x minus 2. Can I go any farther?
No.
No, so I didn't give you any other information. So that's done. Makes sense? Okay, do yours. Done? Did you mess it up?
Not done.
You didn't. I need somebody to mess it up. Zach? No.
Oh, that again. I got this.
Did you do it wrong? Oh,
You're not supposed to carry it over.
Oh my gosh, I'm done too.
Am I right so far?
you wrote down the problem. That's all you've done. So yes, you are right, so.
Yes.
Yeah, I understand. I feel like I'm a pro. You're really just kind of
What's multiplication out of half?
Oh.
How is this one different than what you were doing?
You're adding.
You're adding this time. All right. Did somebody please mess this up? What did you do, Costas? No, quiet. Please tell me. Do you have a problem?
I think so.
Yes. Put it up.
You're grounded again.
All right. This is what I wanted you to do. Some of you were too smart.
Yeah, I thought you were never wrong.
Quiet.
You told me you were never wrong.
Oh, everybody makes this mistake. I don't know why you guys are making it.
Obviously not everybody.
Quiet. Now remember, he's doing it wrong. So don't write this down.
Copy this down in your
False
notes.
information.
Well, at least you copied it.
Okay. All right. Why is that wrong?
Because I didn't think X was a different thing, but I had to put in the log.
All right. If for this to be right, the 9x would have had to be in parentheses. Then Costa would have been right. Okay, is it in parentheses?
It's on my paper, it is.
Yours printed different than everybody else's. Okay, what are the two things I'm multiplying, Zach?
You and Jen, I tell ya.
9 and x to the 5th. So how do we rewrite this? Tell Lauren, thank you.
Thank you.
Okay, how do we write this? Log to the 3rd of,
Three.
no, what's first?
9
9
plus
plus log base 3.
x to the 5th.
Okay, what can you do with the first term? 3 squared. So this becomes log base 3 of 3 squared, and that equals what?
2.
So this is 2. Plus, what can I do to the second term? Now what do we do? Now we move the 5 to the front. Can I do? No. Can I do anything else with that? No, because I didn't tell you any more information. So that's done.
See, I like the 2 with the 10.
You can put it either way, it's fine. All right, question. Do you see where the mistake comes on this one? It's a very easy mistake to make.
Would we ever get one where it's in for us?
Yes,
Good. I'll be ready for that.
good. All right, now we're going to use properties of logs to solve.
Oh,
Okay,
good.
sometimes they're easy, sometimes they're hard. This is the harder one because the log is only on one side of the equation. When the log is on both sides of the equation, they're actually easier, even though they look weird. So I've got the log on one side of the equation, and you got to start with your rules. Mason, what does addition mean? Yes. So what am I multiplying?
Are we looking right now?
That's what you're telling me. Yeah, I have to multiply the x times the x minus 9. Good? So I got log base 6 of x times x minus 9 equals 2. Can I do anything else with the log?
Yeah.
Not yet. So I need to get rid of it. So how do I write something in exponential form? No, it's Denton's turn. So you did this last time. Okay, Denton, go. How do I write it out of log form?
The log out
This.
of form.
How do I get rid of the log there? I have a log on one side, so I can rewrite it exponentially. So how do I do that? Come on, Denton. You just did it. What's the last one you did? No, the logs go away. No, you don't get it. Just take it out. What's the base? What's the exponent? No. That's the answer. No. Kelly. 2. Remember, logs find exponents. So that's the exponent. So this is 6 squared equals this. Are you there? So 6 squared equals x times x minus 9. Everybody okay?
Mm-hmm.
Okay, now we do our FOIL, our distribution. So you have x squared minus 9, and then brought this all over in one step. Everybody okay? Now from here, I don't care how you solve it. This was a really simple factor. Because factors are 36 that give you 9 or 12 and 3. I have no thought involved. But if you wanted to use the quadratic formula, could you? Yeah. You can use any of those methods you learned. I don't care. Just solve it. Good so far? All right, so you get 12 and negative 3. The only problem is the logs are picky. You're not done. You have to check your answers because sometimes they work and sometimes they don't. Because when you take them out, you're introducing roots that are not necessarily there. Okay? So you have to plug them back in. So we take the 12 and we plug it back into the original problem. Good so far? Okay, so I have log base 6 of 12 plus 12 minus 3, which is 3. What's addition mean? Multiplication. So this is 12 times 3, which is 36. All right. How do I rewrite this? Denton? Rewrite this out of log. Yep. What's the base? What's the exponent? What's the answer?
62.
Thank you. So that means 6 squared equals what? 36, is that true? Yes, so this one checks, so 12 is an answer. Good? Circle that. Now we have to plug in the -3 to the same problem. Type in log base 6 of -3 in your calculator. -3.
Domain error.
Domain error.
Mine says your teacher told you some dumb joke. Mine says you did 2.3.
What? It should have given you no answer.
I got minus 2.32.
Oh, not all of you got. Okay, if you do not have log base 6, if you can't do a log base 6, you have to do this here using your change of base. So log of, no,
10? 3.
-3 divided by log of 6. Okay, sorry, forgot that part. Did you get an error? Did you get an error this time?
I got error.
Errors?
Error.
Okay, that's because that's not possible.
Cannot.
Right, so you have to check that. So -3 is not possible right here. So this is not a solution. You have to check log answers, not an option. Everybody good? All right. You got to practice. By the way, yours is ridiculously easy.
Oh, it's really.
It really is.
Oh. Oh, geez.
Shit.
Oh, dang it.
Oh, God. I was hoping to learn more.
I'm gonna stay after school.
All right, I'll take you up on that.